Hey guys, your boy Chill here. Welcome back to C++ Game Engine Infrastructure. Today we're going to be looking at some test automation. It's going to be an interesting topic to dive into. It's something I want to kind of explore in the context of game programming, game engine programming. So let's just jump right in there. Now, in the last video, if you recall, we set up our namespace, our policy for namespacing, and for how we're going to set up our file system. And while doing that, I incorporated the IOC infrastructure that we had built in previous videos. But this one is a little different because we separate out singletons from the container. And that difference, I didn't explain it. I promised I would explain it in this video. And we are going to explore that interface by writing unit tests. Tests are a great way of actually doing documentation. So a lot of times, let's add a new project. A lot of times you'll get like an open source project. It's not gonna have a lot of documentation, but if you look at the tests, you can see how the parts of it are used. A little tip for you. But anyways, so native test. All right, so we got a bunch of options for this. Like, I mean, obviously not this C#, not a lot of these apply, but one that does apply is Google Test, and I think that's probably a better test framework. But I'm going to use the Microsoft one because this is a Microsoft product. It's probably going to give me the least friction. I don't want to spend tutorial time monkeying around bullshit. So, what are we going to do here? Well, we've got this unit test added. As you can see, the template that adds it in also does stuff that I don't like precompiled headers. Somebody actually made a comment on a previous video saying, Chili, why don't you use precompiled headers? And I mean, I've been burned by them in the past, but you know, maybe it's time to look at them again, but the time is not right now. Like maybe soon, but not right now. Right now, I just want to do the things that will give me the least friction so I can focus on the things that I want to talk about. All right, so we get rid of the precompiled header stuff. Now, obviously very important. Again, these templates, they like to give you the x86. They like to slip you a little bit of the x86. You just got to say thanks, but no thanks. We'll go edit, remove the Win32, and we're good to go. Now, last thing, we go to our property manager. We have things the way we like them, and we can do add existing property sheet, go up to our solution root, add our baseline, and it's in both of these flavors, and everyone's good to go. All right, so now that everything is like that, what do? We could build, could make sure that this stuff builds, and of course it doesn't build. Wait a minute, it did build? It did build. Okay, cool. Cool story, bro. How do you run your tests? That's a good question. You could probably run them from the command line somehow. But a nice thing about test frameworks is they usually give you a test runner to run your tests and to report back, you know, aggregate all the results. And another nice thing is that usually good ones will have integration into your IDE of choice. So if we go to a Test Explorer window, which as usual can be found in your view area here, Test Explorer, we see that after we build, actually, it populates this thing here. Unit test, test method. So we have a lot of options, a lot of places for organization here. We can see the test method probably corresponds to this. This one corresponds to this. This one corresponds to the namespace. And I think this one corresponds to the project. So if you have multiple test projects, they'll show up here as separate routes. So cool. We can run our tests like this. A little different than running from here. Nothing happened. There were no problems because we're not testing anything. There's no code. So let's change that. Let's do a little testy. We're going to test our test. Include core source IOC container. There we go. So let's test out container boy, and we'll just actually use the code from here. So I'm gonna copy this one here. We'll put that in here. We need the test structures. to do this stuff. So let's put that in here. What else? Let's change this one to just simple resolve. That'll be the name of this. File name. I'll just rename this one quickly. So we'll put all of our IOC tests in a single source file here, although you could do multiple, I guess. We'll do this one, IOC tests. And the namespace, I don't know, let's do a namespace infrastructure, you know. I don't know how exactly I want to organize this stuff yet, to be honest. But that's not how you spell that, is it? That's not how you spell it. Infrastructure. There we go. Perfect. Okay. So there's a little bit of complaints here. Understandable. Using namespace chill will get rid of most of them. Now the other thing here is that when we're doing tests, we don't just spit data out to see out, because it's not for a human to read. The point of test automation is that you automate this stuff. So you should have an automated way of checking whether or not something is doing what you expect. And the way you do that with the Microsoft framework is there's a assert class with a bunch of static methods on it. So we want to assert r equal, and we put in the expected value, which is 69. And then we do the testing value, which is going to be IOC get dot resolve, and that's a thing. Get the base type, and then we're going to call test. So that'll return a value. The value should be 69, but we'll see. So if we build this again, we should see build failed. Right. So what we're saying here is unresolved external symbol. That makes sense. When you have multiple projects, as we have already established, you have to add a reference to the ones that you depend on. So we depend on the core. That's what we're testing. So that's what we build with. Very easy to add dependencies like that. Here's another interesting one. We got a warning here, and this is something that I've actually alluded to in the static analysis video. Microsoft, they in their infinite wisdom wrote some code that is not exactly compliant with best practices. And maybe that's because they want this code to be able to be used pre-C++ whatever, I don't know. And either way, this little warning here is going to be annoying, and we'll probably deal with it in the way that I explained in the static analysis video. But for right now, we'll just ignore it. Our build more or less succeeded. We go test explorer, unit test, infrastructure, IOC tests, simple resolve. We run it, and it succeeds. And there you go. We have run our first test. Now, what if we didn't get what we were expecting? Let's change our expectation here. It's going to rebuild when I try to run the test. And then it's going to run the test. And bam! Assert failed, expected 420, actual 69. It'll bring me to the place where the assert was so that I can see, hey, there's the thing that didn't work. Let's go ahead and add a second test method. We'll see how we like it here. So we are going to do a simple resolve failure. So we're going to try to resolve something that doesn't exist. So how do we do that? Well, if I remember correctly, if I recall, I believe that we coded up our IOC container such that when we don't find anything, we throw a runtime error. So if we try to resolve and it doesn't exist in the container, we should get a runtime error. Cool beans. Let's try that. So how do we check to make sure that an exception is thrown? Expect exception. So we're going to expect an exception. The expected exception type, I think, is a template parameter for this one. So let's do std runtime error. And then in here, we can just like put maybe a lambda. and the lambda will be the code that should throw the exception. So just, bro, calm down with your spacing there. So the thing that we want to do here is we just want to resolve base. Now this should fail, it should throw an exception, which is expected and caught by this assertion, and the test should succeed. So failure is success, basically is what I'm trying to tell you. So let's build. We should see this thing populate with a second test. Here we see simple resolve failure. This one failed. I guess this one runs all tests, is how that works. Simple resolve failure failed. What? But last time it passed. Let's try to run them all again. Failed. What if I run it by itself? Pass. So who among the class can think of why we might have this problem? All right, now I'm going to tell you. So one important thing about tests is that generally tests should be independent of each other in terms of state. Our tests are using this singleton, and the singleton here, it's going to maintain state between calls. So we call, if simple resolve is called before simple resolve failure, what happens is it's going to register base into the IOC container, and that will then be available when we call this one. And that's bad because we want to test the case where it wasn't put in there in the first place. So how do we ensure that all of our tests are independent of each other? Well, there's a couple of pieces to the puzzle. The first piece is something that we actually already solved. And so you might have wondered, we're creating this singleton. You can see the singleton manifested here in the get function has this local static that's returned. So this is what gives us the singleton. So basically this is a global object. And we have this global object and it has one piece of data. And then we can call member functions to operate on the data. Now you might have thought to yourself, Chili, why are you bothering making this class instance, making this instance data, and then making a global? Why not just make a single global unordered map, and then all of your functions here, they don't have to be class functions, they can just be normal free functions. Why are you bothering with making this class in the first place? Why not just make it all global and you don't need the class bullshit? And the reason why, well, one reason why, is because it's very nice to be able to create an independent instance that isn't global. And this is a perfect example of that. What we actually want to do is before each test is run, we want to spin up a fresh IOC container so that we're starting fresh. We're not carrying over state, which can impact how our tests run. So the second piece of the puzzle is, okay, how do we set things up so that we can get a fresh instance before every test? I mean, we could write the code in every test here. We can create an IOC container, but that's a little annoying. There's actually a better way of doing it. So let's make a private section here. And I am going to include memory. So let's do a std unique pointer IOC container p. Let's do PIOC. That's fine. So here's the magic sauce. So we're going to use this macro here, test method initialize. And code that you put in here will be run before each test method is run. And what we're going to do is we're going to do PIOC is equal to std make unique IOC container. And there you go. Now we create a fresh IOC container before each test is run. Now if we go to the Test Explorer, we run them all again. We see that it still fails because, of course, I messed up. I shouldn't I shouldn't be using the singleton. I should do PIOC, pointer to register. Place this one here, and then we'll run our tests again. And this time, doesn't even build. Right, because this is a lambda. So we should probably capture this pointer. Okay, certainly this will work now. And it did work, thank you very much. Bob's your uncle. Now we have tests, and they are not muddying them up, each other up with their carried over state. All right, looking over at my OBS timer, it seems like I've already burned a decent amount of time just teaching the basics of Microsoft Unit Test. I had planned to write tests that show usage of all these functions on screen, but I don't think that is going to be in the cards, but that's fine. What I'm going to do instead is I will write the tests off screen. I'll commit them to the Git, and then if you're interested, you can look at the tests and try to see if you can understand the API from the tests. Maybe I'll even add some comments in there. It'll be a good exercise. But one last thing I do want to do on the video is show how we can deal with that annoying. We got a warning in here. We obviously can't just edit this file. I mean, we probably could, but it's not a very good idea. So there's a bad idea for a number of reasons. So what we can do instead is, before we include cpp unit test.h, we can disable that warning and then bring it back afterwards. How we do this is we write a wrapper, because I don't want to do that in every single test file that I make. So I'm going to make a new item. I'm going to make a header file, chill cpp unit test. So first thing we do pragma warning push. We push the current state of warning configuration. Then we do pragma warning disable. We want to disable the one that's giving us problems, which is 26433. You don't put the C in there, you just put the number. Then we include cpp unit test.h, and after that we do pragma warning pop. This allows us to maintain the static analysis for our code, just don't use it on Microsoft's jank code. So we probably should put the little brackets, the parentheses around that. Let's rebuild it again. Apparently it doesn't fail if you don't do that, but let's make it proper. All above board. And there you go. No warnings to be seen. But if I were to remove the override here, I believe our static analysis would pick it up if I save the file. No, I did pick it up. It just took a while. And then if we rebuild the solution, we should see the warning so that we can see, yes, our code is being statically analyzed, but Microsoft's code is not. There you go. So just a little demonstration of a wrapper header for the purposes of disabling warnings. And then we can include this chill cpp unit test in all of our unit test source files as we build them up. But yeah, so I will, off screen, I'll write a bunch of test methods. You can check them out if you want, or you don't have to. I mean, I'll be using the IOC container in other videos. You'll see me be using it, and you'll understand how it's used in that context if you want. So it's no big deal, really. It's nothing, and it's not something that I want to spend a lot of time on videos going over. Not necessary. But that is a little introduction to unit testing here. Oh, one last thing that I wanted to talk about. This is actually quite important to me. Writing unit tests for all of your code is kind of a big overhead. It can add a lot of extra development time. But think about it this way. Generally, when you write code, you're adding a new feature, there's probably a lot of moving parts to the feature. And you can't just code them all up and integrate them into the system all at once, even before doing a single build. Like I've done it. I've been there before, and I'm sure you guys have been there too, where you have this feature, you code the entire thing up without building once, and then you try to build it and it doesn't build, and there's so many errors. And even after you fix all the build errors, there's so many bugs. And because you've coded up so much stuff, it's hard to narrow down which part or parts is screwing you over. So that's why we generally like to build iteratively. We build a small thing, small part of the feature, and we make sure that builds, and we test that, and then we build more parts, and then we integrate them together, and finally we integrate them into the existing system. When you're doing that, you have to write throwaway code to test all the iterative parts that you're building up. Instead of writing the code and then erasing it when you're done, write the code in unit tests and then keep it around. That code will remain, and that will be testing all the different subcomponents. And then when you refactor those components, 2 months later, a year later, if your refactoring breaks some previous expectations, your test automation will catch that and will tell you. It's very beautiful. So I'm not saying that we should have 100% code completion, or even like 50% code completion. All I'm saying is that if we write throwaway test code while we're building something, let's not throw it away. Let's keep it in a unit test. And another part about this is some things are easier to unit test than others. Some things that involve, for example, graphics output or any kind of output to the user, networking, they're much more difficult to test, right? And I'm not going to be going crazy trying to get 100% code coverage or anything like that. But I do kind of, in the future, I have an idea. I want to try to explore unit testing graphical output as well, using something called snapshot tests. But that's an idea. I don't even know if I'm going to go there. But if I do, that's definitely for the future. Not anytime soon. But yeah. The main thing I just wanted to say here is that we can do unit tests, and they don't have to add a lot of additional work, as long as we're smart about it and we just use them to keep throwaway code and don't throw it away. If we do that minimum, then we won't be adding much coding overhead, but we will be getting an upside. Anyways, that's it for this video. If you did like it, please click the like button. It helps a lot. And I will see you again soon with some more C++ game engine infrastructure.